Good morning everyone. Today we are discussing about the forward and inverse kinematic of 2 degrees of freedom of a robot in 2 dimension. After completion of these presentation, you must understand the concept of forward and inverse kinematics of 2 degrees of freedom in 2 dimension. So this figure shows a forward and inverse transmission for a robot with two joints. So let L1 be the length of the first link, L2 be the length of the second link, and the end effector is attached on the end of L2. Let theta 1 be the angle of first link with respect to reference of x axis, and theta 2 be the angle of second link with respect to first link. So x axis is the reference axis. So total angle of the link with respect to reference is theta 1 and theta 2. From the figure, what we have to find is total x distance and y distance. For forward kinematics, the angle is given and we have to find the x and y distance. So first we take link L1 and find x and y. Then take link L2 and find x1 and y1. At last we have to find the total distance x and y. For the first link, it is at an angle of theta 1 with respect to reference. We have to draw an imaginary triangle. That is, so we have to calculate x and y distance. So to find the x distance, we have to take what? We have to take cos theta. To find the adjacent side, we have to take the cos. So cos theta equal to adjacent side by hypotenuse. Here the adjacent side is x1 and hypotenuse is y1. So cos theta equal to x1 by y1. So x1 equal to L1 cos theta 1. Next we have to find y distance or vertical distance. So to find opposite side, we have to take sine theta 1. Sine theta, for basic equation of sine is sine theta equal to opposite side by hypotenuse. So sine theta 1 equal to y1 by L1. So we have to find y1 equal to L1 sine theta 1. So next we have to consider the second link. So like this we have to find x2 and y2 for second link. So we have to find the second link alone. L2 be the length of the second link and at an angle of theta 2 respect to first link. Total angle with respect to reference is theta 1 plus theta 2 for the second link. So we have to draw an imaginary triangle at the second link. Let L2 be the length of the second link and theta 1 plus theta 2 is the angle of the second length with respect to reference. X2 is the horizontal distance and y2 is the vertical distance. Same as that of first link, we have to find the equation of x2 and y2. So x2 is the adjacent side. So we have to take what function? Cos function. So cos theta 1 plus theta 2 equal to x2 by L2. So the value of x2 equal to L2 cos theta 1 plus theta 2. Next is y2 is the opposite side. So we have to find what? Sine function. Sine of theta 1 plus theta 2 equal to y2 by L2. Then y2 equal to L2 sine theta 1 plus theta 2. Next we have to calculate the x distance. So we calculate total x distance by adding x1 and x2. So x equal to x1 plus x2. So same way we have to find the y distance by adding y1 and y2. Y equal to y1 by y2. Here we get the large equation for x and y. So total distance x equal to L1 cos theta 1 plus L2 cos theta 1 plus theta 2, and total y distance equal to L1 sin theta 1 plus L2 sin theta 1 plus theta 2. That is the final equation for forward kinematics of 2 degrees of freedom in 2 dimensional. Next we go through what? Reverse kinematics of in reverse kinematics or inverse kinematics of 2 degrees of freedom. So we just find the equation for forward x and y, that is x equal to L1 cos theta 1 plus L2 cos theta 1 plus theta 2, and y equal to L1 sin theta 1 plus L2 sin theta 1 by theta 2, squaring and adding both the equation, both the x and y equation, and we have to consider a plus b the whole square equation inside that. So we get the, after all these derivation, we get the value of theta 2 equal to cos inverse of x square plus y square minus L1 square minus L2 square the whole divided by 2 L1 plus L2. So that's all about the forward and inverse kinematics of 2 degrees of freedom. Hope you all understand. Thank you.